Yes, good morning. Is the screen visible?
Yes, sir.
Yeah. So I gave you one homework about how to find the median for discrete frequency distribution. Anyone has the answer? No one? Yes, Apurva Srivastava, Vedang Shivsagar. No one can answer this simple question. It was a homework and no one did it, I guess. Aaron, Aditya, Patil.
Hello, sir. I tried it, but I wasn't able to solve it.
Okay.
And there was another method, Manas told yesterday. I know that the second method, I didn't get it.
Okay. Okay, so the idea is, anyways, if you are not trying for this, then I have to give you the solution. I have to go ahead.
So
Anyways,
28.
so 20, 20, 40, 49. So 49 divided by 2. So that is 28.5. Oh, sorry,
24.7. 24.5.
24.5. So the what we need to do is we will actually find out the cumulative frequency curve, less than cumulative frequency curve, and that is going to be 6. Then this will become 20. So this will be 28. Then the next one will be, oh wow,
40.
440, and this will be 49. So the cumulative frequency just exceeding 24.5 is this,
20.
and the corresponding value of x is 2. So the median is 2. Okay, so this is how you find out the cumulative frequency for the discrete frequency distribution. And you can see that this is just the what you can say extension of your basic definition of median. In median, what you did was you arranged all of them in increasing or decreasing order, and then you look at the middle entry. Okay. So when you write down the less than cumulative frequency curve, what you're doing is you're taking zero, how many times? 6 times. Then you will write down 1 for 14 times. And when I say n by 2, so this is how you are going to get. So it is just the extension of your basic definition. Yes. Now the next question, how can you find out the median using graph? Anyone?
Sir,
Yes.
if we plot a graph, then the highest point is going to be the mode.
Okay, you're talking about mode. I need about the median
Oh,
first. Mode is correct. Exactly that. That is how you are
oh.
going to find out the mode.
For median, it's going to be the middlemost point.
And how can we get that point?
So by
According,
intersection of less than and more than.
yeah.
Okay. By intersection of less than and more than. If I have just less than, so for any data, what we can always draw is the of course less than cumulative frequency curve and more than cumulative frequency curve. Then we will have the value of n. So what I can always do is I can draw the line for n by 2, right? And when we put the perpendicular from n by 2 on the x-axis, this point of intersection is going to be median. Okay. For a mode, of course, if x and f are given, okay. Again, let me just to the next mode. One is if x and f are given, right? So if x is there on x-axis and the frequencies are plotted on y-axis, so whichever point you are having the maximum frequency, you can directly say that it is the mode. But now, if you have this kind of case, say for an example, you have class intervals given to you and you have frequencies. Then this formula changes a bit. If you remember, it was L plus Fm minus F1 upon 2 times Fm minus F1 minus F2 in bracket complete. Hello, hello.
Yes, sir.
Uh, Sorry, there was a connection problem there. I don't know where you got disconnected.
Sir, you wrote the formula till H. After that,
Yes. So I was saying that once we have this formula, it means that the mode that we need to find out, it won't be just simply the maximum frequency and we can take the class mark of it. It's not possible when you have continuous frequency distribution. So in this case, what we do is we use the histogram, and using histogram, what we can do is we can find out the mode. So what we have done is we have the class intervals there, and we can always draw the histogram. You find out the modal class. How do we get the modal class? Modal class can be found using the highest frequency. So in the given data, what we do is we look at the highest frequency, we declare that class as the modal class. Then what we can do is the class preceding the modal class is the pre-modal class, and the class succeeding the model class is the post model class. And we have drawn a line from the upper limit of pre-model class to the upper limit of the model class. And we have drawn a line from lower limit of the post model class to the lower limit of model class. Whatever is the intersection, we take the perpendicular on the x-axis, and that point is the nothing but the mode. And then I have written a relation between mean, median, and mode. The relation is mean minus mode is equal to 3 times mean minus median. So which difference is larger? That was my question. Which difference is larger, mean and mode, or mean and median?
mean and mode.
Mode. So mean and mode has the largest difference. Please remember this. So in some of the cases, it may be difficult. If you have the mean and you have the median, there is no need to actually go for calculations of this mode. You simply use the mean and median, use this formula to get the mode. Fine. Next is the geometric mean. Yes. Geometric mean of n observations is defined as nth root of their product. So if x1, x2, dot 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 till xn are observations, then geometric mean GM is equal to, yes, anyone who can formulate this? And please keep responding. Don't be idle. Latasha,
nth root of x1, x2, and so on xn.
okay. So that will be under root into x1, x2, dot till xn raised to 1 by n. Okay. So this will happen for the raw data. So if we have the observation in this form, say if we have xi comma fi, where I is running from 1, 2 up to k, is the frequency distribution. Then first of all, I hope you understand what do we mean by this xi comma fi. So it means that the observation xi is repeated fi times. Now, how we can write down the formula?
Is it the xifi root of under root of xifi n times?
Xi fi product.
Yeah, like x1 f1 into x2 f2.
Okay,
Then
okay. Mrunal.
Sir, can I?
Yes, of course, Hasnan, please.
Sir, it will be xi multiplied xi will be multiplied by itself fi times.
So
Like
how do you write it?
xi, where I equals to 1, then x2, x3, x4, x5. They, all of these terms are multiplying fi times. Means k
Okay.
times over here.
Huh.
And this will be the root of 1 upon k.
Okay.
So,
Manas?
Yes,
there will,
it would be xi raised to fi into
Exactly.
x. Yes,
Exactly.
and under root 1 by k. Under root k. Kth root.
No. Okay. Please mute yourself. There's a lot of noise going on. Uh-huh. So Hasnan said it right, but it wasn't actually compact one. Uh, just the power I want to change. The power, the root actually. So xi. So x1 raised to f1, because what is in the bracket, that is the product of all the observations. So x1, if I see, it is repeated f1 times. So when you take x1 into f1 times, that will become x1 raised to f1. Similarly, x2 raised to f2 dot xn raised to fn. And it is 1 upon the number of observations. How do you get the number of observations? Oh, sorry, this is fk raised to xk raised to fk. How many observations do you have?
The sum
Manas.
of the frequencies. The sum of the frequencies.
Exactly.
F1 plus
It's not k. Okay, so that will be 1 upon n, capital N, where capital N is equal to summation fi. So as you can see, if you are doing it manually, it is going to be very much difficult. Even if you take 2 raised to 10 and 3 raised to 7 and this kind of things are there, then it will become very much difficult. Okay, and calculating such large numbers will make the job very much tedious, and that's why we have another tool. What is the tool? What is the tool?
Scientific calculator.
Yes, so one way scientific calculator. The other one is we take the log to make the things easier. Okay, and whenever we have an example on geometric mean, we'll do it using log because log will make the things easier. Quickly, one example on the same. Find geometric mean of 2, 8, 20, 62, 54. So geometric mean is 2 into 8 into 20 into 62 into 54 raised to 1 by 5. So the answer is what is the answer? You have the scientific calculator or not?
So the answer is coming out to be 2 fifth root of 6 cube multiplied by fifth root of 155. But how can I change the format the answer is coming?
You I hope you're able to see this button on your calculator. P double implies P by Q. I don't remember actually. This double implication sign must be there.
Double.
Yeah, if you press that, you will get the answer in decimal form.
So there isn't any.
Yes, the answer is 16.0.
Yes, sir, got it.
Got
S implication D.
Yeah. So a double implication sign button. If you press that, you will get the answer in decimal.
Yes, sir, got it.
Okay. So we will simultaneously look at our other way of finding the geometric mean. So G is equal to, what I can do is, if I take log on both the sides, so what is the formula? G is equal to um, product of xi's raised to 1 upon n. So if I take log on both the sides, what I will have is 1 upon n log of product of xi's. Yes. If this n, so if I'm working with xi raised to fi, say, let's not deal with it right now. Xi raised to fi. So we'll have this kind of thing. What is log of a into b?
Log A plus log plus log.
Log A
Log
plus
a
log B.
plus log
Log
b.
A plus log B.
So this I can write as 1 upon n log of summation xis. Oh, sorry, summation of log xis. I'm so sorry about this. Summation log of xi. Okay, and then you have 1 upon n, and on the left hand side you have log of g. Log of g. So g is equal to nt log of 1 upon n summation log of xi. That is another way of doing it. Okay. So you can maybe try this later. Nt log 1 upon n summation log of xi. What we simply need to do, we need to take log of 2, log of 8, log of 20, whatever addition you get, divide by 5 and take anti-log. Okay. Remember that in your calci, there are two logs, log to the base e, which is represented by ln. Okay. So let me just write it down here. ln is log to the base e, and there is log is log to the base 10. Okay, remember that which log you are using. While doing integration, we usually get log to the base e. In this case, you can take log to the base 10 and later anti-log of log to the base 10. Fine. The last one is the harmonic mean. The harmonic mean is defined as harmonic mean is defined as reciprocal of arithmetic mean of reciprocals of observations. Read it carefully. So if x1, x2, dot till xn are observations, then harmonic mean hm is given by yes, anyone?
Yes, sir. N by 1 upon x1 plus 1 upon x2 plus so on 1 upon xn.
So that is summation 1 upon x size. I is running from 1 to n. 1 to n. So this is how we find out the harmonic mean for the raw data. What if we have the distribution in the form xi, fi with i's running from 1 to k?
So it would be summation fi upon summation of xi, 1 upon xi.
Just tell me again.
Summation fi
Summation fi
upon
uh,
summation of 1 upon xi fi.
summation of 1 upon xi fi.
No, that would be wrong.
Then anyone else? Yes, Haroshiri,
Yes.
Sakshi. Yes, can you tell me how will you find out the harmonic mean here?
Do we have to take the log again?
No.
Yeah. Okay.
So,
Sakshi. Yes, Manas, please.
summation fi upon summation fi upon xi.
Exactly.
Because
So what is said that you need to take the arithmetic mean of reciprocals of the observations. So if xi is the observation, then I need to take the mean of 1 upon xi. And how many times 1 upon xi is repeated? It is repeated fi times. So that is going to be summation fi upon xi. Fi upon xi. I is running from 1 to k. This is how we find out the harmonic mean. Now today's homework. Find a relation between arithmetic mean, geometric mean, the harmonic mean. We'll have to study all the cases under which what happens, and then we'll discuss this in the next lecture. But with that, let's just write down the definitions for quartiles, percentiles, and this is for this. Okay. Partition values. So the topic is the partition values. So of course, every time what we can do is we can have the variable along the x-axis or the observations along the x-axis, and we have the frequencies along the y-axis. So this kind of setup can always be there. So observations and we can have the frequency along y-axis. We have the observations along x-axis and frequencies along y-axis. So I will plot the data and we get a curve something like this. Now I want to divide this whole portion or whole of the observations in, say, 4 parts. How can I do that? First of all, can someone tell me median divides the observations into how many parts?
So two parts.
So
Two.
median actually divides your observations into 2 parts. So sometime now what I'm trying to do, I will divide this total observation into 4 parts, and that will be known as the quartile. Quartile. So what is the intuition behind the quartile? So it is dividing the complete observation into 4 equal parts. Median divides the observations into 2 parts. So deciles will divide the partitions into, sorry, observations into 10 parts. And if I talk about the percentile, then it will divide the observations into 100 parts. Okay, so I'll simply write down the definition here. The observation which divides the observations Q1, Q2, Q3, which divide the total number of observations, which divide the total number of observations into 4 equal parts. Into 4 equal parts are called quartiles. I have written Q1, Q2, Q3, and I'm saying that 4 equal parts. Why?
Sir, because one
One
is a
from zero.
median, and the rest of the two, we need the rest 2 parts of the median which are already divided. We need 2 points to divide them further. So this are 3.
Okay. Look, area you are dividing. An area will be divided by 3 points. If you make 3 vertical lines in this, so the total area will be divided into 4 parts, as you can see. This is the first line, I will say, the second line, and this the third line. So if you draw 3 lines, your area is divided into 4 parts. So this first, second, third, and fourth. Okay. So by quartile, what I mean, the first quartile, I mean the first point. Second quartile, I mean the second point, and third quartile, I mean the third point. So what you are doing is, I'll just rub the below things, and with the same, I'll give you the formula also to find out the quartiles. Deciles and percentiles we won't be using much, but we will actually need to understand what are the quartiles. So by first quartile, it means that the total area is divided into how many parts? 4 parts. So the formula will be like this: L plus N by 4 minus CF into H by F. This formula looks similar to that of
Median.
Median, exactly. So in medium, you were taking n by 2. In this case, you are taking n by 4. You took n by 2 because the median was dividing it into two parts. So now, if I want to get the second quartile, so this is 1 by 4th part. So 2 times 1 by 4 will be 1 by 2. So L plus 2 times n by 4 minus CF into H by F. This is nothing but and the third quartile L plus 3 times n by 4 minus cumulative frequency into H by F. What is this? This is median, right? Q3 L.
Yes, sir.
Yes.
Yes.
So with the rough idea of quartiles, I just want you to think on. So deciles are denoted by dk. Which decile will be median? First question. Which decile will be median? My first question. And the second is, can you guess the formula for dk?
Sir,
Kth
fifth
decile.
one and the
D5.
formula. Sir, the
D5.
formula will be L plus
Just a minute. dk is equal to, yes,
L plus
L plus
6 times n by 4 minus
d. Why 6?
so 6 will divide in equal two parts.
Decile means
10.
10. You need to divide the total area into 10 equal parts.
Okay, sir. So 10 equal parts.
So can I say
Yes,
L plus
L plus
uh, n by 10
n by 10
minus CF
uh,
upon F upon H by F.
n by 10 minus Cf into H by F. That's it.
Yes, sir.
Will it be same for all the deciles?
Maybe.
Mm,
So I
then
guess the n by 10 would be multiplied by 5.
5. Why 5?
So because it's decile, so 10, so median would be 5. Like 5
Yes,
would
median.
divide.
You're talking about median. Um, uh, okay, let me go to the next page. So decile. How many deciles you will get?
9.
D1,
9.
D2,
9.
it will go up to D9. Which divide observation, which divides the total observation into 10 equal parts. Observations into 10 equal parts. So we will need a formula for each of them. D1, D2 up to D9, right? Now I am asking in general, what will be the formula for dk? So as Sakshi said, so it is L plus n by 10 minus CF bracket complete H by F. Then someone made
Okay.
a change in this, and that was
So the n by 10 would be multiplied by k, I guess.
yes, exactly. So this n by 10 will be multiplied by k. So if I want the first decile, so I will put the value of k as 1. If I want the second decile, I will put the value of k as 2. Now, and then the second question was, which decile will be equal to the median?
5, 5th.
Fifth one, exactly, because if I put 5 into n by 10, that will become n by 2. Next one, what will be the formula? How many percentiles we will have?
99.
99.
99 percentiles we will have. Those are denoted by P. It will go up to P99, which will divide the total number of observations into divide the total observation, the total observations into 100 equal parts. PK, next formula,
Same as deciles.
L plus K into N by 10,
10 will
100.
be replaced by 100.
100, exactly, minus CF into H by F. Okay, some important remarks here. These remarks will help us understand these things much better. First one, median is equal to Q2, which is equal to D5 and P50.
5th.
Okay. Can you relate D1 to some of the percentile? First decile will be equal to which percentile? Can you guess that?
25.
Why so? You must get
So
D1
10.
yes,
10.
exactly,
10th percentile.
10th percentile. Then D2 will be equal to 20th percentile, right? Why this is so is for D1, what you are going to have in the bracket, D1 will be n by 10, right? And when I'm talking in terms of percentile, so 10 into n by 100, right? So that will become n by 10 in the bracket. So 10th percentile is becoming the first decile. I hope it is clear to everyone. Q1 is equal to which percentile?
25th.
Exactly,
25th.
25th. So 100, I mean, you are dividing 100 into four parts. That's it, right? So how will we divide 100 into 4 parts is thus taking 25. If you want to go by theoretical way, I mean to say by mathematical way, you can take the formula for P25 and simplify it. You will get the formula for Q1. Fourth and the most important one, it says that the partitions are not equispaced. Partition are not equispaced. However, the area under the curve, however, the area under the curve between two successive partition, area under the curve between two successive partitions values of the same values of the same type is same. So this means that if you look at the area between any two successive quartiles, that will always be 25% of the total area. Fifth one, Q1 is always less than Q2 is less than Q3. This is obvious because this is the first 25% part. Then we again add 25% part, which becomes 50% for Q2. That's it. Any difficulty in this, please ask. Mark your attendance. We are a bit late today.
Explain the fourth point. Partitions are not equally spaced. I didn't understand it.
There are two things like I'll draw the curve here. The curve is like this. Okay. If you look at the area, there is a large area concentrated here in this part. Okay. If you add this and this area, it will be very much less than this part. Okay. So the remark says that you are going to okay, I'll just so we have this much this is the curve. Okay, and now I'm dividing this into I'm making quartiles out of this. Q1, Q2, Q3. Your whole of the area is divided into three parts. Okay. Now, as it is divided into three parts, this Q1, Q2, Q3 are not equispaced. I mean, distance between Q1 and Q2 is going to be greater than the distance between Q2 and Q3. That is what I mean by equispaced. So these are not placed at equal distance, but whatever area you have, this area will be equal to this area.
Okay.
Okay.
It's a
Fine.
quartiles will be independent of number of observations. No?
Yes. Okay, fine. Please mark.
Okay, sir.